In the silent vacuum of space, where light from the sun is faint and the cold is absolute, Saturn spins with quiet majesty. Its golden rings shimmer like the edges of a crown, delicate yet powerful, tracing patterns across the void. To the human eye, Saturn is beauty perfected, the most photogenic planet in the solar system. But beauty often hides complexity, and Saturn is no exception. Beneath the elegant arcs of its rings, beyond the serene clouds captured in distant telescope images, Saturn holds secrets that baffle even the most seasoned planetary scientists. Some of those secrets, like its ever-present hexagonal polar storm or the mysterious dark beads falling into its atmosphere, may change the way we understand gas giants altogether. These are not minor curiosities. They are anomalies in planetary science. Glimpses into the inner workings of a world that refuses to behave by the rules we thought we understood. The phenomenon began with a whisper in the data. During its final years, NASA's Cassini spacecraft detected unusual signatures in the high atmosphere of Saturn. Dense, falling clumps of material streaking through the planet's gaseous layers. They weren't shaped like beads, not literally, but they behaved like raindrops, falling, dispersing, sinking. They appeared suddenly, darker than the clouds around them, heavier than expected, and still unexplained. Scientists began referring to them colloquially as dark beads, a visual metaphor for what was being observed. A sort of strange planetary drizzle, not of water or methane, but something heavier, possibly carbon-based, possibly tied to ring debris. Cassini's instruments revealed that Saturn's rings are constantly shedding particles, tiny grains of ice, dust, and possibly organics, that spiral inward under the influence of Saturn's gravity and magnetic field. Some of these particles don't just burn up, they survive long enough to alter the atmosphere itself. These beads, then, might be part of a cosmic recycling process, the rings feeding the planet in an eternal loop. Material born of Saturn's formation, now returning to it after billions of years. And yet, we still don't fully know what they're made of. Some speculate they might be charged clusters of silicates. Others believe they contain complex hydrocarbons, maybe even the byproducts of photochemical reactions in Saturn's upper cloud layers. Their precise nature remains elusive. It's not just a mystery of composition. It's a question of process. Why do they form in clusters? Why do they fall at certain latitudes and not others? Why do they appear seasonally? The dark beads remind us that even in a place we've studied for decades, new phenomena can still surprise us. Then there's the hexagon, Saturn's most famous, most bizarre, most persistent mystery. Discovered during the Voyager flybys in the early 1980s, the hexagon wasn't even believed at first. A six-sided storm? In nature? On a planet made entirely of gas. It looked too artificial, too perfect. But later, Cassini confirmed it. Not only is the hexagon real, it's gigantic. Over 30,000 kilometers across, it could easily contain 4 Earths, side by side. It rotates with Saturn's atmosphere, locked in place for at least 40 years, and possibly much longer. What's more, it hasn't changed shape at all. While hurricanes on Earth drift and dissolve within days or weeks, Saturn's hexagon is stable, symmetrical, and persistent. How can this be? At its core, the hexagon is a standing wave in Saturn's upper atmosphere, a region where high-speed jet streams circle the pole at over 300 kilometers per hour. Under certain conditions, fluid dynamics allows for polygonal wave patterns to form and remain stable. Scientists have replicated hexagon-like flows in laboratory tanks, spinning fluids inside cylinders. But again, These are controlled experiments measured in centimeters. Saturn's version is measured in planetary scale. The physics might be similar, but the scale is utterly alien. Worse, its southern pole shows a completely different behavior. No hexagon, just a swirling, cyclone-like vortex that behaves more like a massive hurricane. Why only one pole has this geometric pattern remains unknown. And perhaps most haunting of all, deep infrared imagery has revealed that the hexagon extends far down into the atmosphere, hinting that it's not just a surface-level jet stream, but a structure with depth and dimension, potentially anchored to layers far below what we can currently see. To solve these mysteries, Cassini would have to go where no spacecraft had gone before, into the space between Saturn and its rings. This region, sometimes called the Ring Gap, was previously avoided due to fears of particle collision. But in 2017, during its grand finale, Cassini braved this narrow zone 22 times, diving closer to Saturn than any probe in history. It sampled ring particles falling into the atmosphere. It mapped the planet's gravity and magnetic field with unprecedented precision. And it directly observed the upper reaches of the polar vortex, capturing new details of the hexagon's winds, structure, and possible vertical extent. In those final moments, before Cassini was deliberately plunged into Saturn to avoid contaminating the moons, it sent back clues that may take decades to fully analyze. Among them, unusual chemical signatures, ion flows, and the faint presence of those dark beads still falling, still unexplained. Cassini died in Saturn's embrace, but its data lives on. Perhaps the greatest revelation of all is this: Saturn is not static. It is not a cold, unchanging gas ball. It is alive, not biologically, but dynamically. It breathes, shifts, evolves. Its rings are evaporating. Its storms are growing and dissipating. Its interior may still be contracting, slowly releasing heat formed billions of years ago. The dark beads and hexagonal storm aren't isolated anomalies. They're symptoms of a living world, a world in flux. And what's more, they remind us how little we still understand about the basic mechanics of planetary weather, structure, and time. Cassini gave us a golden age of Saturn science, but it also raised questions we can't yet answer. To go further, scientists are calling for a new generation of missions, a dedicated Saturn orbiter to study the atmosphere, internal rotation, and deep weather systems. Atmospheric probes, like those sent into Jupiter, to sample Saturn's deeper layers. Instruments that could directly measure the descent of ring material, and possibly even watch the beads fall in real time. Polar orbiters to unlock the secrets of the hexagon, the vortex, and what lies beneath them. Some are also calling for a return to Saturn's moons, especially Titan, with its thick atmosphere and methane lakes, and Enceladus, with its plumes of water vapor and potential signs of life. But the planet itself still deserves attention. We've seen the rings. Now it's time to listen to the heartbeat within. In many ways, Saturn is the planet of paradoxes. It is massive, but less dense than water. It appears calm, but hides storms that last for centuries. It looks symmetrical, but is wildly asymmetric beneath the surface. It's a planet we thought we knew, until we realized we don't. The dark beads falling through its skies and the hexagonal storms spinning at its pole are more than anomalies. They are messages from a planet still shaping itself, a world still dancing with the gravity of its rings, a sphere of gas still whispering the secrets of planetary evolution. One day, we'll return, and when we do, we may not just explain the beads or solve the shape of the storm. We may find that Saturn, more than any other planet, holds the key to understanding how planets live, breathe, and die. Not just out there, but maybe here on Earth.